The quotient rule, part 2. In its simplest form, again, we'll use the prime notation, meaning the derivative. So the derivative of f of x over g of x, or I can just say the derivative of f over g, equals g times f prime minus f times g prime over g squared. Kind of a complicated little formula that you can mess up pretty easy. So I have a little poem here, and I'll read the poem. Low d high, less high d low, draw the line and square below. Well, low means the denominator, high means the numerator, d means derivative, okay, and less means minus, okay. So it's low, we take the denominator g times the derivative of the high, the one up high, less high f d low. We draw the line and we square what's below. And if you get it backwards, the poem won't rhyme. So you can't say low d high, less high. You can't say whatever. You can't get it backwards anyway. It won't. It'll mess up. Let's see how you could get it back. You go high d low, less low d high, draw the line and square below. It wouldn't rhyme. That's how you can mess it up. So if it's low d high, less high d low, draw the line and square below, and you won't get these backwards. That's the main thing. Okay, here's our example. Again, I'll use prime notation because it's the easiest thing to use, the cleanest thing to use in a very complicated formula like this. So I've got I have the function x squared over 2x minus 1. It's a rational function. And what I'm thinking is I'm going to take low, this, times the high, derivative of the high, low d high, subtract less high d low, draw the line and square it below. Now all I have to do is take these derivatives. By the way, this step is called applying the rule, and it's very important if you're taking a calculus test and to get partial credit. If you can get this much down and then you make a little error, it'll mean that you really understood it. And so it's a good step, and besides, it's easy to go backtrack and see if you made a mistake. Well, we know that the derivative of x squared is 2x, and we know the derivative of 2x minus 1. Of course, minus 1 is 0, the derivative, and this is 2. We know that's going to be 2. So we've got everything. Essentially, we're done here. We have no more derivatives to find, so we could leave this as the answer, but I think we can do some simplification. If I distribute the 2x there and the 2 here, I end up with 4x squared minus 2x squared, and simplify further down to here, and I think that's as simple as you can get it. And so in conclusion, here we have it. This was the original expression, and this is the derivative.